Alright, so what we want to do, I want to take us into the textbook, and we're going to focus here on the section 4.3, modeling the trends, right? Modeling the trends. So here we go, and I just want to start with some examples. How much more do people tend to weigh for each additional inch in height? That's what we're going to do here. And I went into the data sets that's available to you as well if you want to practice and work with these. But it was about the age and the height of children. So I'm gonna just go through this, and hopefully I can edit out any of the parts that I need to while I'm thinking. But anyway, okay. So here's what we're gonna do. Notice this one, and the reason why I started with this one is because it shows us something that can be done maybe easier, maybe about the same. But notice we have two categories of data. We have a male and a female over here. So if we're trying to do, let's do, I think this is, let me just test here. Okay, I always forget which way to go. Sorry about that. There we go. So, yeah, this appears to be centimeters, right? So, so we have heights in centimeters, and then we have height in inches. Let's just use the age in inches because we're most likely to be familiar with that. So we have that one. So what we want to do is do calculators. Remember, we're doing modeling, which is aggression. We're doing aggression. We're doing regression. Sorry, simple linear. And let's let age be the predictor variable, or we would call the independent variable x, because time keeps on marching, right? You can't stop the age. You can't stop the height either, but this is sort of dependent upon age. So now let's do the height in the inches. All right. Now, since we have two categories, this is one thing that StatCrunch does pretty easily, and that is being able to group by the categories or the variables in this category, or the categories under this variable. The variable would be when we're talking about stack, the variable is the column head. So that has two possibilities, male or female, right, in this scenario. And let's get, I always like to grab with the prediction interval, fitted line plot along with the prediction interval. And that's about it, really. We might get into residuals. I can't remember how far we go into those. But we could do that. You could actually predict with this if you wanted to, but we'll get to that here in a moment. But we got everything set up, I think. I don't know. I haven't really thought about the color stuff. I guess you could basically do that. I just use the basics of it. Anyway, let's run it here. And as you can see, that's what we have. We have for the females, we have it broken down like that. And we have the intercept, the slope, right? Up here you have the equation. It tells you here's your correlation coefficient, and that's a pretty good predictor. Age is a pretty good predictor of height. But notice r squared. Remember, r squared is whatever percentage of x, which x in this case was age, age is an 82.1% predictor of height according to our sample. And that's very important. Not universally, according to what we have in our sample. Okay? And hopefully we did a sample the way you're supposed to be doing it by randomizing your sample. Then notice of course it'll give us our stat plots, which really one thing nice about StatCrunch is that when you hover over the line, it reveals the equation. That's cool. You can hover over a dot and reveal the information from the particular dot. It won't do a predictor, but see, that's where, let's just do this while we're in here. Let's edit it. And so sometimes that's what you're usually, that's why it's called model. That's why you're calling it a modeling. You can see up there, modeling. So let's see. Let's just predict what our model would say for somebody that just turned 21. And this is our level, 95% confidence. This will make sense later. But anyway, let's go ahead and here, let's compute it. And here should be, yes. So when a person is 21, they should be between, is this female? Yes. That's pretty tall, right? Pretty tall. But that's what it says. But that's what we got. I'll double check on that. But anyway, so we said 20. Oh, look what I just did. I extrapolated. Notice the time was age height for children, so it's only between these age groups, starting at age 2 to 21. And notice our data point says 21, and look where the predictor model is. Let's just try to go easy. I can never do it. Anyway, yeah, see, that predictor model is over predicting. Definitely over predicting at that point. So see, as your age is starting to get older, you know, you really quit growing, but see, that age is going to keep going up. And I would guess that this would level off in the long run. But anyway, that was an interesting little discovery. And looking over here now, it did make the predictions. And this one should be for the males. Let's look at what its prediction values are. So it says that 21 is predicting someone to be 76 inches. Let's see. See, the data says still so 68, but 6 foot is 62. That just seems a little high, but definitely predicting that 76. Just out of curiosity. So I think it's 76 inches. So what was it? I was predicting 76, so we'll go with that. Darn, I lost my thing. There it is. So 76 divided by 12. Well, that's 6 in 6.4. It's not as large as I thought, but it's definitely an over prediction, right? So definitely over prediction. Anyway, that's kind of what we discovered here. So in the next one, I think I'm going to take this same data and do it in Excel. So that'll be what we'll be doing next.